All right, so this is section 5.4. It's the fundamental theorem of algebra. And basically what that says is that if you have a polynomial function, which we do here, and the degree is larger than 1, okay, which we do have that, you're guaranteed to have at least one zero. So the equation, when graphed, will cross the x-axis once or not. It may not, but you'll get a solution, okay? You could get a non-real solution. So it just says that you're guaranteed to find some answer when you set x equal to 0 or y equal to 0. So in here we have 3 steps, and the first has 2 parts. We want to find the degree of the polynomial, and then we want to identify what the y-intercept is. Okay, so the degree, we're going to count the number of exponents or x's we have if we were to multiply this all the way out. So notice there's an x here, and it just has a second degree. So this counts as 2 x's, okay? So I'm going to write that out. We have 2 for that first term. All right, and then in this second term we have an x. Now the whole expression doesn't matter, but we're just looking at the variables. And this has a third degree, so that we have 3 there. So I have 2 plus 3, and then this last set we have one more x here. It's understood to be first degree. So we have to just add up how many of those variables show up. 2 plus 3 plus 1 will give us 6. So if we multiplied and FOILed all of this out, we would end up with an x to the 6th power up front. So our degree is 6. And then we have to find the y-intercept. Okay? So what you need to remember about the y-intercept. When you're looking for the y-intercept, note that x is 0. So all you have to do is plug in a 0 for x, and when we do that, the first expression will simplify to just 5, because 0 plus 5 is going to be 5, and you still have to square that, and that is being multiplied to, if you plug a 0 in for the next x, you have a negative 1 there, and that is cubed. And then if you plug a 0 for that last x, you just end up with a minus 2. So all we have to do is raise these to these powers and then multiply this out. So we get 25 times negative 1 times negative 2. So all together you get 50 positive. And x is 0, the y value is 50. You have to type it as an ordered pair. So I would do parentheses and then 0, comma, 50. So this gives you your y-intercept and your degree. Okay, part 2 wants to know the x-intercepts at which f crosses the x-axis. So how many times will it cross? Okay, so you notice a few different things. These guys are already factored out. These are our zeros, okay? Look at the degrees. Okay, if the degree is 1, okay, that means it crosses. So x minus 2, if I set that equal to 0, I add 2, we get that x equals 2. So this graph will cross the x-axis at 2. Okay, if you have a degree of 1, it definitely crosses. All right. If you have a degree that is bigger than 1, so this x squared term, when you set that equal to 0, there's 2 of them really. But when you do x squared, this gives you a 0 of negative 5. It had a degree of 2. When you have a degree of 2, that's kind of giving you this parabola shape. So anything that is a second degree is going to come down and touch and go back the other way. So this one doesn't cross, it just touches. This one will cross. Then we have one more. That was a third degree. So that was the x minus 1 as a third degree. But anyway, when we set x minus 1 to 0, we get that positive 1 is a 0. When you get a third degree, so any odd degree will cross. So third degree, what that picture will look like is your graph will come down, it'll kind of flatten out, and then it'll cross anyway. So this turnaround also is called flatten out. So any odd degree, 1, 3, or anything else will cross. Even degrees, this was a second degree, those will just touch and turn around. Okay, so we have 2 of these that have odd degrees, the 3 and the 1. and they want to know what are those intercepts. One of them is going to be 2, 0, and the other one is going to be 1, 0. And then now the third step, we want to find the zeros where it flattens out. Okay, so kind of what we just talked about. Here, when you have a degree bigger than 1, it's going to flatten out no matter what it is, even or odd. And the even and the odd both flatten out. So there's 2 of those that flatten out, and we're going to list those zeros. So as ordered pairs, we're going to have -5, 0, -5, 0, and then we repeat the 1, 0. Okay. It falls under both categories. It flattens out and it also crosses. Okay, so number 2, similar problem, not as much there, so you can do that one. And we'll do something different here.